Number 5 is a big question, and it all revolves around Group 7. So once again, hopefully you get the point that Group 2, Group 7, the descriptive chemistry is a very important chunk of the course, and you've got to learn the facts as well as understand the principles to do a good job in this paper. So first of all, it's asking us to think about van der Waals forces in relation to Group 7, and the first question requires us to explain what those van der Waals forces are. This again is a set piece that you really should try and prepare in advance, because it's a very difficult explanation to make up on the spot. So the idea is, first of all, that you get instantaneous dipoles. Okay, so an individual molecule can develop an instantaneous dipole, which means it's a dipole that just exists for a short time, but you can just use that phrase and explain that this happens as a result of random electron movements within the molecule. Okay, so you need to get that idea that because the electrons are moving around randomly within their orbitals, at any one moment in time you can get a dipole which just exists for that short time, which is called an instantaneous dipole. Then, in nearby molecules, the electrons move in sympathy with that, and that's called an induced dipole. Okay, so we get an induced dipole in nearby molecules as a result of the instantaneous one in that molecule. Okay, so again you need that phrase induced dipole in there. And finally, you can then explain that you get attraction between the dipoles, and that's what the van der Waals force is. Okay, so that's the points that you need to get the marks for part 1 there. Then we've got to state and explain the trend in the boiling points of chlorine, bromine and iodine. So obviously you need to know what that trend is, and you're hopefully familiar with the idea that chlorine is a gas at room temperature, whereas bromine is a liquid and iodine is a solid. You need to know that. And what that means, of course, is that we're already above the boiling point of chlorine, but we're not above the boiling point of these two, and because iodine is a solid, you can guess that we're quite well below its boiling point. So the boiling point is increasing as we go down the group, and you need to state that for 1 mark. Then you've got to explain it. Now, we have a sort of general strategy for how to do boiling point questions, and you can effectively apply that here. So the first thing in a boiling point question is to establish what kind of structure the substances have that you're comparing. So is it giant ionic, or is it giant metallic? Is it giant molecular, or is it simple molecular? Those are the possibilities. So the answer in this case is that these are simple molecular substances. Okay, you've got Cl2 molecules, or Br2 molecules, or I2 molecules. That means they're simple molecular. Then we said, okay, what does that mean in terms of what sort of forces you have to break? Okay, so what sort of forces have to be broken in order to boil the substance? And the answer is, if it's simple molecular, then it's the intermolecular forces, not the covalent bonds. Not the covalent bonds. That's the key thing that you need to be very careful about. When you're talking about intermolecular forces, you need to try to be quite specific, if you can. In other words, is it van der Waals forces, or is it permanent dipole forces, or is it hydrogen bonds? And in this case, the answer is van der Waals forces have to be broken. Okay, so you've got to state that as part of your answer, that these forces have to be broken in order to boil it. Then you've got to relate the boiling point to the strength of those forces. And the point is that the van der Waals forces get stronger as you go down the group, and that's going to be why the boiling point gets higher. Okay, so they get stronger as you go down the group. And the question is, well, why do they do that? So we need a because in here. Now, we learned 2 factors that can affect the amount of energy needed to break van der Waals forces. The first one is the number of electrons per molecule. because the more electrons per molecule you have, the stronger the van der Waals forces are likely to be. And that's the case here. Obviously, as you go down the group, you're adding more electrons into the molecules, and so the van der Waals forces get stronger, and that's the main point here. We also learnt that the surface area can be important, because the bigger the surface area, the more points of contact with other molecules you have, and therefore the more van der Waals forces have to be broken. If you've got a difference in number of electrons, that surface area thing is usually a more minor point. So look for the difference in number of electrons first, and in this case that was all you actually needed to explain. Only if that doesn't appear to be the explanation, because there isn't much difference, or indeed because it's going the wrong way, do you then have to think, well, maybe it's a surface area thing. But it's important you get that priority right, because in this particular mark scheme, if you only talked about surface area, you wouldn't get the marks. So think about the number of electrons first. Okay, so stronger van der Waals forces as you go down, because you get an increasing number of electrons per molecule. And finally, you have to say, well, what's the point about the increased strength of the forces? And you have to relate that to the energy needed to break those forces. And you might think that's obvious, but it's not obvious to the examiners. You've got to spell that out. So because they get stronger as you go down the group, the energy needed to break them increases as you go down. Okay. So that's the answer to the question, but make sure that you not only understand that in this particular question, but that you learn that general strategy to compare the melting points or boiling points of any set of substances they choose to ask you about. Final question on that page is about astatine, and it says, why would you expect it to react similarly to the other halogens? I mean, that's a huge question. You could write a whole book about that, but it's only 1 mark, so obviously that would be inappropriate. All it wants you to say is that they have the same number of electrons in the outer shell. Remember, that's what makes elements in the same group have similar properties. Don't just say because they're in the same group. That's not enough. You've got to say, well, so what does that matter? And the point is that elements in the same group have the same number of electrons in the outer shell. Okay, the rest of question 5 we'll do in a separate video, because otherwise it gets too long. So we'll stop there for this one.